So this week we're going to start to distinguish between vector and scalar quantities and give examples of each. So in expressing a quantity, we give it a number and a unit. For example, 12 kilograms. This expresses the magnitude of that quantity. Some quantities also have direction. A quantity that has both magnitude and direction is called a vector. On the other hand, a quantity that only has a magnitude is called a scalar quantity. Vectors are represented in print as bold and italicized characters, for example, F, capitalized, italicized, bolded. So down here below is a table with some of the vector and scalar quantities that you'll come across. So scalars, you might hear referred to as speed, temperature, distance, area, entropy, volume. Vectors having magnitude and direction, you might hear velocity, acceleration, displacement, force, momentum, and drag. So keep an eye out for these. Both are physical quantities. That is what they have in common. Scalar has magnitude only. Vector has both that magnitude and direction. So you might be surprised that you've actually seen a few vectors already during this presentation. So again, just to get you used to some of these terms that you'll see, some vector quantities might be displacement, velocity, force, momentum. A scalar with only a magnitude has mass, time, temperature. So you'll see magnitude represented as this line as the quantity, and direction, which only vectors have, not scalars, represented by the head of this arrow. So you've actually seen a vector a couple times in this presentation now already. So you can think of it as, if you think of it a physical object, a lot of metaphors are often airplanes or cars. So the car is traveling in a direction at a certain speed. So speed might just be the magnitude, and then the direction of the direction the car is moving is obviously the direction then of the vector itself. So vectors can be added. They can be additive. Vector A plus vector B can equal vector C. So we're going to work first just on the positive axes for y and for x. So you see here a positive A vector, a positive B vector. They're both going up and to the right, as indicated by the direction, which is the arrowhead. Now, as they are both moving in the same direction, A plus B can actually equal C, which is a total additive vector. And you can see that in any exponential version of A and B, as long as they're all being multiplied or have the same exponent. So Cx equals Ax plus Bx, Cy plus Ay equals Ay plus By. So C equals A plus B in this very simplest of examples. So for your group projects, what you're going to do is you're going to do a series of experiments. You're each going to do an experiment. So across the top here in the spreadsheet that you can download from this lecture recording later is the experiment that you'll each be doing. So someone's assigned to 1, someone's assigned to 2. You're all going to put a series of results. So you're going to focus on, let's say you are going to focus on experiment number 1, and you're going to put 7 results in there. So you're responsible for filling out your column here. It will average it out for you automatically. It'll also update this trend line automatically. So let's take a look at what that would look like. So here I'm going to look at the spreadsheet itself. So as you update your experiment and you start to see others update theirs, as they put their results in, you'll see that the trend line will actually change. So what our plan is to demonstrate the impact that different vectors and information can give on a graph. Eventually we'll be learning how to build these particular graphs with the trend lines, but first when you put your experiment data in, we want to see how each experiment and each result affects the next. So make sure you download that from the assignment or from this recording, and we will tackle that at the beginning of the next class.